Good evening, ladies and gentlemen, and welcome to the second webinar hosted by the IRTE Ireland North Committee. My name is Michael Hutchinson, and I am a technical trainer for heavy vehicle and light vehicle up at TTS in Northern Ireland. I'm also the education officer for the IRTE Ireland North region. I'd like to a very warm welcome to everyone this evening. The webinar this evening will be split up into three parts. It'll be a short speech from myself. I would also delighted to welcome Dr. Peter Waters, Mr. Brian Elliott, and Mr. Martin Madine from Translink. But the first part of the webinar this evening, we're going to be looking at the development of the modern diesel for heavy goods vehicles. The diesel engine has come a long way from the early days of when startup and there was large plumes of smoke that filled the yard and took a long time to clear. But the main driving force behind that has been the EU emission standards. And the current emission standards that we're on at the moment is Euro 6. The emission standards are designed to reduce NOx and particulate matter or soot. This has been achieved with various emissions reduction systems. One in particular is EGR, or exhaust gas recirculation, where a partial amount of the exhaust gas is sent back into the combustion chamber to be reburnt. Another one is DPF, or diesel particulate filter, which again is trying to reduce the amount of soot or particulate matter in the emissions. And finally, selective catalytic reduction and AdBlue. The current emission standard is, as I mentioned, Euro 6, but the Euro 7 is due to come into force in 2025, which will narrow down again even more for those emissions output from the vehicle. Of course, another important aspect which should not be forgotten is the health implications of emissions. It's estimated that diesel vehicles contribute to around 10,000 deaths per year across Europe due to respiratory and cardiovascular diseases, which of course is a shocking statistic. The next step on our timeline then is the electrification of heavy goods vehicles, or purely electric. It's of course is a challenge with a heavy goods vehicle due to the weight and the range requirements of the vehicles. However, there's a lot of manufacturers, original equipment manufacturers and independent pioneers that are developing e-axles and making this a reality out on the roads today. And again, this is going to have a massive help to achieving the net zero emissions by 2050, if not sooner. This then brings us on to the next step of the timeline, which is the hydrogen fuel cell electric vehicle. And I would now like to hand over to Dr. Peter Waters, who is a self-employed mechanical engineer specializing in high pressure gases. Dr. Waters.
Good evening, everybody. The title for the presentation was UK skills development, and the point I'm trying to make in a lumbered way is that if you're going for a specialism in hydrogen skills, your kickoff point is probably a level 3 diesel apprenticeship or vehicle electrical apprenticeship, and I'll explain in due course. If you're looking at, if I go to that now, next slide, page 9. Oh, I just have to wait a second. Any youngster now looking at how the skills and where we're going, we've got to look at the skills market. And one of the things I'm going to look at is I'm going to look at the market for young people's engineering skills. I'll look at skills development in terms of hydrogen fuel cell technology. I'll talk a little bit about hydrogen fuel cell electric vehicle innovation, particularly in buses where it's more advanced than it would be in trucks. But trucks are obviously catching up. And then what I'll do is I'll lead into the presentation from Brian and Martin at the end, and then we'll all do a table question and answer at the end. Please, along the side of the presentation, if you put up questions, we'll try and address all the questions that you write up as we go through the presentation. We've discussed, the last 15 years of diesel development and the European standards, really to do with PM10 and NOx and local urban pollution. From the last 2 years, you've now seen a global emergency being declared. And in response to that, the UK and certainly the Irish governments have got carbon zero 2050 targets. And you're beginning to see an investment in green technology in cars, buses, trains, and aircraft. The problem about that is the investment in those vehicles will be in small numbers. They'll be leading edge technology. And most of the young people that we're trying to attract into our industry are going to be working on the older legacy vehicles. Okay, we're targeting hydrogen, all the investments in hydrogen, but if we follow what's going on in the States, what's likely to happen is people won't want to invest immediately in hydrogen vehicles because there's no hydrogen infrastructure. What they'll do is they look for drop-ins, and we're living with drop-ins now as far as unleaded petrol and ethanol. It's a liquid drop-in replacement with low carbon claims. In terms of diesel, we've got fatty acid methyl ester and other forms of biodiesel. Myself, I'm working in biomethane at the moment. We're about to commission one of the first biomethane plants in Ireland for truck applications. But Caller have got bio-LPG, and in Sweden there's extensive use of LNG from anaerobic digestion and liquefaction. But tonight what we're going to talk about is electric vehicles. And within an electric vehicle, what you've got is a sophisticated alternating current motor drives, DC battery storage, mainly lithium. You're looking at fairly big kilowatts and lots of amps. You've also got hybrids, and you've also got hydrogen fuel cell vehicles. This is what the filling station looks like this year. And starting from the left, and if you look at the little nozzle now, you'll see all sorts of different badges. In preparation for this slide, I found out that there's at least 12 different electricity plug and socket arrangements, depending on whose charging system you use. Ethanol, fortunately, is coming out of the unleaded nozzle. Hydrogen is slightly set to one side, natural gas and biomethane, and propane's been available on the forecourt for 20 years. The driver that, in the next 30 years to convince people to move across, as far as the motorist is concerned, is at the moment biomethane and bio-LNG where I'm working. You're looking at about 10 pence per kilowatt hour. Hydrogen at the moment is 0.26 for hydrogen, and that's the green hydrogen. And the target is that when green hydrogen gets to 2.6 pence per kilowatt hour, effectively, because there's zero CO2, it will fly, and effectively nobody buy diesel anymore. So you've beaten to the chase here. What am I saying to you is my advice, particularly in an organization such as SOE and IRTE, where you have an opportunity to speak to young engineers like Martin here, is to watch the vehicle market and look to enter this industry with level 3 apprenticeship, either as a vehicle electrician or diesel fitter. And through this, we're on Zoom this evening. Any of you that haven't used a multiple open online course before now, the big issue as far as physics in terms of hydrogen is concerned is there's a lot more maths, physics and chemistry coming in terms of fuel cells. Because if we look at the components of a hydrogen bus, there's a lot more maths, physics, chemistry, a lot more IT in the systems. We're looking at youngsters entering the industry to become competent at operations, maintenance, and innovation. And if they're looking at a business, they should be looking at the leading edge of the market to see who the people are going to be. For instance, in Northern Ireland, we've got a hydrogen bus manufacturer, but we also have someone, a materials handling company, and they've got hydrogen-powered hydrogen-powered forklift trucks and handling equipment. And they're the only people that I found in Northern Ireland that actually manufacture fuel cells. The technology level is going to be much more like the apprenticeship model in Europe. Say, for instance, the Germans and the Dutch, where they would probably be at the end of their apprenticeship at level 4 to level 5. Over the last 6 months or so, following on from a couple of successful hydrogen projects, we've been working with Transport Industry Training Board, and we did look at the IMI work. It's developed 2 national occupational standards. And I'll show you in a wee minute what that's about. But the issues that I'm trying to address today is we need to start getting people into collaboration with professional bodies such as SOE and IRTE in the expert role to effectively set up mechanisms to train trainers, and then look at the cost benefit analysis for accredited courses. In my lifetime, I was fortunate. I gained undergraduate experience with ICI Fibres. ICI Fibres, part of the ICI organization, used to train hundreds of youngsters every year. And industry in general, the larger companies used to, train apprentices. Nowadays, increasingly in Northern Ireland, I'm seeing small to medium-sized enterprises training apprentices. And effectively, they then get poached by the bigger companies. A lot of the manufacturers for the technology are leading the technology, the likes of Ballard, Luxfer, and the various different Swagelok, for instance, manufacturing the components, and they then give competency training based on that. And if you actually looked at the LinkedIn model, there is material available there now where individual learners can go and learn. Some of the material that we've been looking at with Transport Industry Training Board was this one here, which is IMIEV 08, Diagnosis and Faults of Hydrogen Fuel Cell Vehicles. And what it does is it talks about the systems. It actually talks about the skills, the attributes, the knowledge, and the legislation. But the problem I have with this draft is it says, warning, it's recommended by industry experts that only those with suitable training and experience of working on hydrogen fuel cells should carry out the following functions. The problem I have is I can remember hydrogen fuel cells taking the Apollo astronauts to the moon in the early and late 1960s. The technology's been around for 60 years. It shouldn't be fenced off that it's experts. I would like to establish a mechanism where we can put hydrogen fuel cells in front of every technician at some stage early on in their career. And this is some of the takeaway from this evening. How do you become an expert, and how we're going to train trainers? And I've been working with both Brian and Martin here over the last year, so they've got some ideas. You'll see how fast they've come up the line. I don't have time to show you these, but you'll be able to download this presentation in due course. These are 4 of some of the very best YouTube clips that I would offer to show young people who are interested in hydrogen. That top one, the Toyota Mirai one, they actually build the hydrogen vehicle in about 14 minutes. Aberdeen bus, that presentation is very similar to what Brian Elliott could probably give you for Belfast, except he's younger and prettier, and he's got a slightly bigger hydrogen filling station. The Hyundai Nexus and the Luxfer presentations, again, are quite useful. And again, a lot of the technology's out there, so I'm not going to, be too much to it. Among the stuff that I'm giving you here is this website, www.fuelcellbuses.eu. It's a website created as part of a European program, and it's got an absolutely tremendous takeaway from it. And here you've got your hydrogen bus. What you've got is you take out the diesel engine from the back of the bus, and what you do is you put in 2 AC motors to drive the back axle. What you then got is you've got a DC power system, and the DC then converts to AC to drive the motors. The hydrogen sits on the top in high pressure gas cylinders, and what it does is it then goes through the fuel cell at about 9 bar from 350 in the cylinders, and what it does is it generates electricity to charge the battery. So what you've got is you've got a total weight of the battery. The weight of the battery is the sum of the weight of a battery vehicle, the sum of the weight of the batteries, the sum of the weight of the motors. And instead of having lots and lots of heavy batteries, you put in hydrogen gas cylinders and a fuel cell. And what they do is they reduce the weight of the vehicle. And I'll come back to weight in a wee minute or two. I preface this presentation by talking about innovation in the last 20 years. Effectively, if you're looking at that bus design there, that bus design has been running in the United States for probably the guts of 20 years now. The Americans developed that. It's been a very, very slow burner, hydrogen, because fracking gas has been so cheap. All the investment in alternative road fuels has been in CEng. But if you look at Arizona, and if you look at, I think it's Texas, and more importantly, the state of California, absolutely super early stage development work there. And the US government and the Department of Transport's funding a huge amount of research. This particular website, 5 minutes on that website, and you could be an expert. What I'm going to talk, in design innovation, the vehicle weight's critical. The vehicle range and speed, they're important for the use of it. Ideally, the model of the low carbon buses in Britain are going to become battery. Battery basically zero emissions. But there's only so much lithium ion you can get into a truck, and then you have to have a charging mechanism. So you put in a hydrogen fuel cell and hydrogen cylinders and pipework. And at the end of the day, you've got a diesel bus is costing you £200,000. A fuel cell electric bus currently is costing you £500,000. So you can't buy as many. But if you're looking at design innovation, you're trying to drive the cost down. This is a bus that Wrightbus put on the road for the 2012 Olympics at Greenwich. And there were 10 of them built there. And there's the hydrogen cylinders and the hydrogen pipework. Effectively, you'll see that the color has changed in the guts of 10 or 11 years, but basically that was installed with a hydrogen fuel station at a bus depot in Stratford. Unfortunately, it was within the exclusion zone for the Olympics, so basically they had to power it down for the length of the Olympics and then power it up again after the Olympics. But they weren't to know that basically the air defense mechanism around that stadium and the Olympics Village in 2012 was much more important than the low carbon energy buses, 10 hydrogen buses that were on at the time. These are the Van Hool bus. That's Aberdeen on a sunny day in April of 2018. Those vehicles were slightly younger than the Wrightbus and are probably a better seller than the Wrightbus single deck. And they're across a number of demonstration programs in Europe. Effectively, the only way you know that's a hydrogen bus, other than the fact it's very quiet, is you see the wee green badge to the left, to the right hand side by the near side headlights. Basically, very, very quiet bus. So This is a hydrogen bus. The lower connection is the filling connection. And what it is it's like a snap-on connector. It fills the bus to 350 bar. If you look at the top, you'll see a crocodile connection onto a copper hoop. And what you've got there is you've got the wee pressure gauge that gives you an indication of what the fill point's at. These buses were brought into Belfast in December of this year, and Marty and Brian will talk about those later on. There's the back of the bus, and as you see, there's no diesel engine anymore. That silver box down below is about the size of a Euro pallet. Just over about a 1.2 meter squared, and then she's about 600 millimeters tall. And that black thing on the top is one of 6 type 3 carbon fiber gas cylinders that contains hydrogen at 300 bar. If you look carefully, you'll see pipework along the bottom. That's the engine bay fire suppression system. You can't actually see the pipework on this one, but if you think back to the one that I showed you earlier, where the cylinders were on the top, you saw that stainless steel pipe on the top. This is a hydrogen filling station in Aberdeen. It's called Aberdeen Compressed Hydrogen Energy Storage. The little house on the right is the mobile classroom, and there's 2 hoses on this one. And you'll find that there's 2 filling pressures for hydrogen. What you've got is cars, because they haven't got as much space to hide the gas cylinders, are filled to 700 bar. But trucks and buses, because the weight of the cylinders doesn't really contribute too much of the weight of the vehicle, what you've got is you would fill a truck or bus to 350 bar. So you'll find 2 abbreviations, H35 and H70, and those stand for hydrogen 350 bar and hydrogen 700 bar. I'm sorry that photograph isn't good enough, but what you see is when you're paying for hydrogen at the till, you're paying per kilogram. Okay, and typically the buses in Belfast are taking on board about 30 kilograms of 30 kilograms of hydrogen in 6 cylinders. A car might take on board 8 to 10 kilograms of hydrogen, but at a 700 bar pressure. So again, we're coming to the vehicle weight. There is a very, very nice YouTube clip from the chief designer for the Fiat 500. Fiat argue that they've been designing low carbon ever for the last 30 years. The Fiat 500, one of the lightest vehicles on the road, one of the lowest CO2 footprints. The big issue with anybody working in the vehicle industry is, all the vehicles are privately owned except the bus fleet. So this vehicle weight, speed and range, the electric drive, all this innovation that's going on. At the end of the day, Jeremy Clarkson and Elon Musk are a very, very big influence on how fast the fleet is going to change over. Now, you'll hear that Ford and the other companies aren't going to make spark ignition engines or compression ignition engines after, say, 2030. Well, that's not much use in terms of zero carbon 2050, because a lot of the cars, it's 2021 now, many of the cars that are rolling off the production line now will still be running in 15, 16 years time, and could still be doing significant mileage and contributing to the pollution. If you really want to collapse pollution, effectively you have to move much, much faster than maybe you've done with the technology changes in diesel engines. I've struck out vehicle weight and vehicle range and speed, and the reason for that is those are all customer choice. In my lifetime, I've seen the sports utility vehicles. If you looked at all the efficiency gains we've made in the last 30 years in terms of engine management systems and management of petrol and diesel. That has gone largely nowhere because vehicles have got so heavy. There's so much on them. But we as engineers trying to attract youngsters into the business, some of the innovation that's coming down the road is basically electric drive regenerative braking. A large amount of this is about the big 5, 10, 15% improvement in performance will come from the management of cooling of these systems, the driver management, and then the automation. Lithium-ion batteries and the electronics. Again, there's lithium recycling because effectively it's a very scarce resource. And what happens is once you've bought a £500,000 bus, the lithium in that shouldn't cost you that amount of money all the time. Once you get to a certain size, you'll be able to recycle that lithium. And so advents in battery technology, the electronics, the cooling, the safety. UK actually has a lot of technical expertise, mainly in Formula One on inertial flywheels. And if you also look, there is all sorts of development work going on roadside charging of electric vehicles. My area, I'm interested in fuel cells. I'm interested in the efficiencies, the temperature and the cost, water treatment, instrumentation and controls. I talked about hydrogen fuel cells taking the astronauts in the Apollo program to the moon. They used hydrogen and oxygen, and when you generate hydrogen by electrolysis, you automatically generate oxygen. So in terms of energy storage, my view is that in order to get a round trip efficiency in hydrogen, you'll also store the hydrogen. And instead of running your fuel cell to get the energy back out on hydrogen and air, you'll run them on hydrogen and oxygen. And something like an energy storage facility on a wind farm or a big truck is an area where you could balance the risk of having hydrogen and oxygen together on the truck. Because everybody will point to the Challenger disaster where the astronauts were killed due to catastrophic loss of cryogenic fluid. These would probably be permanent gases. So that fuel cell technology, in terms of where we are now, the fuel cells that I'm seeing are the Ballard's ones. That they're up to around about, on buses, they're up to about 85 kilowatt. They've come from maybe 15 kilowatt in the space of maybe 10 years. Effectively, when you get a fuel cell up to the region of 200 kilowatt, what you've then got is something to power a train and something more heavy. In terms of the cylinders, there's various different types of carbon fiber cylinder. The type 3 and type 4 relate to the manufacturer. Type 3's got an aluminium alloy or steel liner, and the carbon fiber's wrapped all the way around it. Effectively, we've got some in Northern Ireland that have got a plastic liner, high density polyethylene with a carbon fiber wrap around it. And we're currently doing some work to extend the life from 15 to 30 years with smart valves on board, and that'll dramatically reduce the cost of that element. Because if you think of a commercial vehicle lasting 7 years or a bus lasting 14, if you got a significant proportion of the cost that has got a 30-year lifespan, effectively the cost of your bus isn't always going to be £500,000. It'll come significantly cheaper as your maintenance technology gets together. And so the sort of smart skills areas that we're coming into, we're going to be identifying wee niches. Two companies are way ahead of us in terms of compression fittings and systems, Swagelok and Parker. And again, they are offering 2-week courses nowadays, bolt-ons for technicians moving into this industry. So where are the hydrogen experts going to come from in the UK? Well, they're going to come from Toshiba and Hyundai, Bosch, ITM in Sheffield, Luxfer, Swagelok, Parker. Some of them are currently, in the universities. Birmingham's got an excellent centre, and we're tapping into some of that. Ulster's got some, South Wales, National Union of Ireland, and Galway. And my view is that the engineering bodies such as IGEM, Institution of Gas Engineers, SOE and IRTE, you'll provide a platform, and we can gift the youngsters who are interested in moving from level 3 to level 4 and 5, the early adopters, we'll provide them the opportunity to generate the material so that they can become self-propelled learners in this technology. Because if you look at how long it's taken to make the changes in terms of diesel engine technology, this really has to move very fast and needs to move from now. Some of the online source material I've actually highlighted here, and again, when you get the presentation, have the opportunity to look. The Ballard material is excellent. The Hexagon Agility, they're the ones that make the gas cylinders. Luxfer make gas cylinders. If you get a chance to thumb through the ZF electric drive catalog, there's some absolutely super stuff up there. Shows you where the technology is. And in terms of the automotive technology related to the rest of industry, I believe you're about 5 to 7 years ahead of the rest of industry. In actual fact, what will happen is the vehicle technology people will lead this low carbon revolution. And the reason for that is that fleets have to be replaced every 5, 6, 7, 14 years. That's much, much faster than the capital replacement value in the traditional energy industry. Bosch have got an absolutely super site, and then what you've then got is this American site from the Department of Energy called Hydrogen Tools, H2 Tools. It's a beautiful wee site. It's a wee encyclopedic site, and it's excellent. The one at the bottom, fuel cell hydrogen joint undertaking EU. That is serendipity. That is Encyclopedia Britannica for hydrogen, and it's all free. The EU has spent 660 million euro on 235 projects, primarily with universities, but each of those projects has learning issues. And if you looked at that EU EC fuel cell bus project there, that all came from that site. So I would encourage you to have a wee look at it. I said earlier on that Northern Ireland, we were looking to reskill people. And what we found was in among the hydrogen, that FCEV, we found a project called KnowHy. And it was an EU program for training technicians developed across University of Birmingham, University of Delft, McFi, and 3 or 4 other players in the industry. Took EU money, developed quite a useful wee project for training technicians. And it's based on an online learning module. And we're weeks away from getting that signed up between the University of Birmingham and Northern Regional College in Ballymena. And the idea is that we're taking some of the hydrogen technology that's been paid for out of public money, and we're recycling that back through technician education. In doing that, I've also spotted that it's very, very difficult for a technician to get their hands on hydrogen. And we've decided to build three designs of hydrogen innovation laboratory. We identified in Northern Ireland that there are 1,200 gas safe engineers who are currently competent with methane. If we blend methane with hydrogen in 10 years' time, all 1,200 need to be competent in methane and hydrogen. So we thought of a mobile classroom where we could actually run it from compressed natural gas, compressed hydrogen into a 4-bar mixer and then drop it down to the millibar pressure that's used. We can actually buy hydrogen and methane mix equipment. Bosch are making it, and a number of the European makers are making it. So that one looks as if it's a goer, and the idea is we would be able to take 120 gas safe engineers and do their conversion course as they come through on their 5-year reaccreditation cycle. And obviously we'd be interested in working with partners across the British Isles to see if anybody else wants to buy one of those. The second laboratory we've got is a 1 kilowatt electrolyzer and a 300 watt fuel cell with oxygen and hydrogen pipework in between. It's based on a project that was run in Paris in 2008 called High Professionals. And what it is we're going to put a PLC control on that one. We'll be able to do all the safety training online before the technician goes into that laboratory. But in that laboratory, they'll be able to ramp up the fuel cell, ramp up the electrolyzer, and watch how basically you put one kilowatt in, and effectively you get about 300 to 400 out in terms of heat. And then how the coolant system and the deionized water, the reverse osmosis water unit works, and how all the analysis works and how all the safety works. And then when you take that hydrogen into a fuel cell, what happens is you also get lots of heat. And then what we've got then is that electricity went in AC, it's converted to DC for the electrolyzer. It comes across as hydrogen and oxygen. It comes out as DC and back to AC. And what's happening is the round trip efficiency is about 30%. When the round trip efficiency, we innovate it and get it, with the input from these technicians that we're hoping to train, if we can get that to 55 to 60% round trip efficiency, that is the stage at which green hydrogen storage really begins to motor. And that is, if over 5 to 10 years, we can take the efficiencies from 30 to 60%, we're addressing that cost challenge of getting green hydrogen down to 2.6 pence per kilowatt hour. We're also working on compression and expansion of carbon fibre cylinders. The reason for that is that when you fill a gas tank, the two ends of the cylinder are 2 different temperatures. You also, with carbon fibre, you'll also see the cylinder expands and contracts. And what we're doing is we're building a wee laboratory so that we can take gas from 20 bar up to 1,000 bar, and then take it down from 1,000 bar to 700 or 350, and then back to 20 inside a confined space. Now, obviously, we've looked at that. We'd love to do it with both methane and hydrogen. The reason for that is methane is a hell of a, you can't actually compress methane above 260 bar, because all you do is you warm the molecules up. The gas doesn't compress down anymore. So that one there we're going to do with argon. Again, what I said at the start here was that, I was pitching this so that, what's next, my personal view of what we would say to, all of us are asked to attend careers talks, for 16 or 17-year-olds at schools, or we've got friends or family coming in board. And my pitch is now for any particular engineering professional body, but what I say is watch the vehicle market. The reason is, my view is that the vehicle market in terms of low carbon is 5 to 7 years ahead of the rest of industry. I would pitch at level 3 apprenticeship level, and really because vehicle electrics and diesel. The reason for that is that student that does that route would get to 20 or 21 or 22 to level 3 with actually money saved in the bank. If they go to university, they wind up with 30 to 40,000 pounds of student debt. And in terms of operational experience through that level 3 apprenticeship, they've got the opportunity through multiple open online courses, maths and physics, to go to level 4 and 5, where we really need to be, and to become a competent operator in terms of maintenance, innovation at the leading edge of the market. And to be honest, I really can't emphasize enough. I know we've all been locked down under COVID, and I'm talking to many people whose heart has been broken by the inability to meet friends and family. But if I've learned anything over the last year, is that we should have come out of lockdown as a result of all this online stuff smarter than we went in. And my view is that whole area, and that's what I'm looking at too, is online technology management at levels 4 and 5. I think I've one more slide to do. I just need to say thank you very much indeed, both to Michael for prefacing me, and for Martin and Brian, who are going to follow me on. I think we're going to take all the questions at the end. The points that I made were a reflection on some study that we've been doing about hydrogen skills development in Northern Ireland, and I would welcome any feedback from the audience. Thank you very much indeed. I just stop this, Marty, and then you can pick up, okay?
No problem. Thank you. Let's see, I just get. Screen. There we go. Good evening, everyone. Thank you for joining us tonight. I'm Martin Madine. I'm the Zero Emissions Project Engineer for Translink. In the following presentation, I'm going to try and run through and give you a brief overview of our efforts to work towards zero emissions within Translink. We have signed the Climate Action Pledge in Northern Ireland, a public commitment to reducing greenhouse gas emissions by 50% by 2030. The UK government in 2019 committed to zero greenhouse gas emissions by 2050 and have now mandated that no new diesel or petrol cars can be sold in the UK from 2030. The UK have set a target now of a 78% reduction in emissions by 2035. Historically, the main emitter of greenhouse gases have been energy supply, but since reductions over the years with greater use of renewables, transport has been the highest emitter since 2016. Here at Translink, we take our responsibility to this very seriously, and as well as the climate emergency that we face, we also have our air quality to consider. In 2019, Public Health England published a review of evidence on air quality. This found that air pollution is the biggest environmental threat to health in the UK, with thousands of deaths a year attributed to long-term exposure. How we live, work and travel has a huge impact on the air that we breathe and our quality of life. A recent coroner decision relating to the unfortunate death of an asthmatic girl, it was declared that road pollution was a direct contributory factor. It is clear that the impetus for attainment of zero emissions is only going to get stronger. Our fleet strategy, I suppose we'll talk about that. We have taken delivery recently of 3 hydrogen fuel cell buses based out of Milewater Service Centre, and we have an order for 100 further zero emissions vehicles coming from Wrightbus, 80 battery electrics and 20 more fuel cells expected in service in March 22. We're running through a project to convert all Belfast Metro, Foyle Metro and Go Line to Euro 6 as an interim measure to help accelerate the move towards a cleaner environment, with the view of having a zero emissions metro fleet by 2030 and the entire fleet by 2040. This is one of the 3 vehicles we took delivery. This was a OLEV project in a partnership with Energia. It involved 3 fuel cell double deck buses, the first hydrogen fueling station in Northern Ireland, and hydrogen is being manufactured on a wind farm, a electrolyzer, so it will be completely green. One that we had to modify the workshop for taking the hydrogen vehicles in. This was putting in fans, ATEX rated lighting, removing the overhead gas heating. I'll just give you a brief cut through of the fuel cell bus we have. If you look at the back here, this is the Type 3 carbon fibre composite tanks. They contain about 26.8 kilograms of hydrogen at 350 bar. Below is the fuel cell. Towards here we have the battery cooler, the electric drive axle, and here we have the electric compressor. This is the same electric compressor that we have in the diesel stick deck. So a lot of items on the vehicle are the same as what we'll be normally dealing with. The fuel cell system consists of three main components. The air delivery system passes air across a membrane with hydrogen on one side, the air on the other. The resultant reaction produces water and electricity as well as heat. The heat is managed by the cooling system, but this is much less than a standard internal combustion engine. The electricity is then sent through the Siemens drive system to charge the battery ready to provide drive to the wheels.
Yep, sure. We'll take a few questions here. So the first question there, as I mentioned earlier, is when looking at the costs, does this take into account the high cost of the infrastructure? I think maybe, Brian, could you answer that one?
Well, I mean, the cost that Peter was, I assume the cost we're talking about is the 500,000 Peter mentioned for the fuel cell bus, and no, the answer to that is no. But there are other costs associated with taking on any new technology. Mm-hmm. Now, going forward, though, if we take the ultimate target is that there will be zero emissions, and that's going to be mandated, then we've got to grasp that now, and that is something that will have to be developed as we develop our fleets and sort of adopt these newer technologies.
Yeah, no, that's a good point. The next question there, do you see the training becoming part of light or heavy vehicle technology courses or as an add-on? I think maybe, Peter, could you maybe answer that one?
What we're looking at is with the innovation laboratories, we've got a cost model for Lab 1, which is for the plumbers, the gas safe plumbers. We reckon the gas safe plumbers will come through that route and do maybe 40 hours of online study followed by 8 hours in the laboratory, and that will be within their CPD cycle. The other modules, what we're looking to do is we're looking at the MOOCs are typically free, and we're trying to spread as much of the free stuff as possible. We've been asked about City and Guilds, about OCN, etc. They effectively take resources that are available for free and can cost 30 to 40,000 pounds just to get a badge or certificate for it. Effectively, I've started just posting stuff up for free.
Yeah, and as you mentioned earlier, the IMI EV07 and EV08,
yeah,
they are going to be a natural progression on from the electric vehicle level 3 and then the electric vehicle diagnosis level 4. So I suppose there is a natural career path there from the diesel apprentice or existing technician and a route for them to go forward. That's great. Martin, if we can hand back over to you.
Our training plan for the fuel cells is to be layered. This will consist start off with safe working on and around the fuel cell, the new hazards we'll have to consider and the new processes we'll have to follow and be aware of that are different from a diesel vehicle, how the fuel cell works, and the different diagnostic systems we have to use. Some of the courses that we'll do will be competency assessed and accredited. For example, the IMI Level 2 award and 3 award in electric and hybrid vehicle routine maintenance and vehicle system repair. New checks and preventative maintenance schedules to learn about. We have to train on leak test and tank valve test and conductivity checking. And these are things that have never been stuff we would have done as a diesel technician, or, you know, so this is all learning for us. Then also we have the other side of it, what we don't have to do in a fuel cell. We don't have to set habits, deal with AdBlue and EGR. The fuel cell service is much cleaner with vastly less waste than a diesel combustion engine, from, you know, 30 litres of waste oil. After the year, because the warranty defects initially would be manufactured by Wrightbus or managed by Wrightbus, we're going to then roll out at a later date further training, which will include working directly on the hydrogen system, manufacturer specific like Ballard, Swagelok, training targeted at a time when we'll be required to carry out specific tasks. So we're getting the right training delivered at the right time when it's of benefit to us. I'd just like to thank you all for joining us. It's an exciting time to be involved in transport and happen to be part of building a sustainable, cleaner future. Thank you, everybody, and hopefully this event has been of benefit to you. I'll just pass you back to Michael.
Excellent. Thank you very much indeed, Martin. I think we'll move on to a wee bit more questioning here. The questions come through is, I'm looking at a hydrogen in a municipal fleet. Do you think that the government will assist in funding going forward as they're pushing the zero emissions route, but as yet we cannot avail of any funding? Peter, could you maybe
honest, if you're not in, you don't win. Translink, together with Energia, watched the calls and answered a call for early applications from the Organisation of Low Emission Vehicles. And that's how the first 3 buses have come through. The subsequent buses, Prime Minister Johnson has been promoting low carbon, certainly within the last 14 months. So you really need a plan for how you'll get hydrogen into your fleet, and then basically do something. You know, like University of Birmingham, they were experimenting with hydrogen refueling in 2007 with the West Midlands Council. Now, it was a fairly crude, simple system, but basically they got going. Even if you get the opportunity to go down to Dalgety, the Hydrogen Wales facility down at Baglin Bay there, absolutely tremendous facility. So, you know, I would say, you know, try and get some money and then see what you can do, and then basically find a champion somewhere who's going to help you push it. But, you know, there's plenty of opportunity there, and there's regular calls. There's a call out this week, I think BEIS, on electric vehicles. Mm-hmm. And if you're not in, you can't win. So, you know, Translink, good luck to them, together with Energia, applied for and were granted 2 million financial support for the first 3 buses. And the EU programs, you know, the UK's alternative.
Next question there, it was just going back onto the question earlier about the high cost, the costs, and taking into account the infrastructure. Yep. Is cost to fuel at the pump, is that why it's so expensive?
Well, at the moment, there are less than 20 hydrogen stations in the UK and Ireland. Effectively, what that means is that the cost of those stations is fairly high. Shell, Linde and ITM are on a rollout to put hydrogen around London. If you go to Korea and Japan, you'll find hydrogen's on a much faster trajectory. And if you go to California, you know, again, hydrogen's on a thing. It's still small numbers. It's still small numbers. And as far as private motor cars are concerned, it's a lot of capital investment for next to no CO2 reduction, because, you know, private cars really don't move it. But if you look at the bus fleets, and if you go for battery operated vehicles and you know, hydrogen fuel cell battery operated buses, they will make a significant amount of difference as government promotes, you know, public transport within urban areas. And as Marty was talking about, you know, Northern Ireland, we have, you know, air quality action areas. Now we're going to have to make it very, very difficult for the private motorist to drive their motor vehicle through that area. So we have to, you know, do what they've done in London, which is make the public transport readily available. So I'm avoiding answering your question because hydrogen looks expensive, but you know, once it becomes, you know, once it gets to a tipping point, it'll and once we're able to manufacture hydrogen equipment in Ireland, the cost will come significantly down.
I think that's the key point to this, in that it's very much a cottage industry in the UK at the present time. We have no proper networks. We have, and that extends not just to the stations but also the production onto the logistics of moving the hydrogen around. So once all those parts start to become scalable, then that will help drive down the overall cost of the operation of running a vehicle with hydrogen.
Yeah. I've got a question here for yourself, Brian. Is there an opportunity for hydrogen skills training to link in with the likes of Translink, bus manufacturers, etc., to get training not just for Translink staff? Would that be a possibility maybe in the future?
Well, it's probably, we haven't thought very far into the future just yet, because as the three vehicles are towing the ocean of hydrogen, and the next 20 coming along will be in next year. And we have been talking to Peter about the innovation labs, and I think there is some level of sort of symbiosis where we can all work together to create the appropriate pathways for people. How that would actually manifest itself and how we could build it wouldn't be quite clear to me, but I do think there are certain opportunities to facilitate, given that there's a low number of vehicles that people would get exposure to. We maybe would be a place where at least people could have a look around and understand and see the shape and size and feel and smell of the vehicles.
Yeah. No, that's thanks for that, Brian. We've got a question here for Martin. Is there much passenger space lost in a hydrogen bus compared to that of a diesel? Some of the components look to be eaten into the passenger space. Is that the case, or?
There's a couple of seats less. I can't remember off the top of my head exactly how many, but it's more down to in this vehicle weight than space. The engine bay, that compartment is all fairly similar size than the diesel vehicle. And these with weight, we kind of a lot of weight involved, not tanks and everything.
Axle loading is the critical factor in terms of the number of seats, as Martin says. That does restrict the number of passengers slightly. It's not a huge amount, and so it is to all intents and purposes, when you got on the bus, you wouldn't be able to tell the difference between the two vehicles until you start counting the seats.
Mm-hmm. Yep. Next question then would maybe be for yourself, Peter. Do you see the trend for battery electric vehicles for private transport and goods under 3.5 ton and hydrogen above that? Or is that possible? So battery electric vehicles below 3.5 ton and hydrogen above, or?
How H2 fuel cell electric vehicles, as I said to you at the start, they're a subset of electric vehicles. Effectively, the hydrogen in the fuel cell extends the range of a battery vehicle. The battery vehicle at the lower weight capacity, like there was a demonstration one we saw in Glasgow, and it was a Volkswagen Caddy, electric Volkswagen Caddy, and the guy had modified himself. He bought a fuel cell and a hydrogen cylinder and strapped them across the rear bulkhead. And to be honest, you know, that was if you were buying you know, small fleet of vans, there'll be a retrofit to extend the range for hydrogen. So I'm not sure how all this is going to develop, because at the end of the day, if you look at the number of people in Northern Ireland, for instance, who are bringing in chassis from Volvo or Scania, you know, there's a wee company up in Antrim I've seen who are basically building refuse trucks. Now, effectively, as soon as they can get a battery electric chassis, I would see the refuse trucks going there. And if you think about that presentation, you had the last one from Arcola about, he was talking, Dr. Kemp was talking about the hydrogen powered refuse truck. You know, we could actually build that in Northern Ireland with our existing supply chain, because all the components are modular. So I honestly don't know how all this is going to develop. What I would say is, in terms of the rest of technology, I reckon you're 5 to 7 years ahead of the rest of industry.
The main factor from our point of view, Michael, is the range of the vehicle. And at the minute, we would very much see battery electric in those sorts of urban areas where the duty cycle, as we would talk about, would be sort of in the 140 miles range. Whereas if we go to 200 miles sort of duty cycle, then we're looking at fuel cell technology. Now, where those two things go in the future, for example, people are talking about 700 bar for heavy vehicles, and that's been discussed. So 700 bar with the same size, or Peter will keep me right here, because the actual tank design would probably have to be modified, but 700 bar in a heavy vehicle with similar volumes of compressed gas would give you a far bigger range. Conversely, improvements in power density and batteries, which have come on significantly in the number of years, well, that keeps developing, then that will also increase and improve the range of electric vehicles. So there is a bit of a mix and match there currently, and that might still always be the case. But where the divide might be, we don't really know yet.
Yeah. I think another question's come here, is maybe one it gets asked quite regularly, is from a safety point of view, if a hydrogen fuel cell electric vehicle is involved in an accident, is there any danger of that pressure in the cylinders releasing rapidly, or?
Well, there are a number of safety devices on the vehicle. And I don't know if you've seen the photograph that Martin showed you. You'll see a couple of vent pipes at the top of the roof, at the rear off side of the vehicle, and they're connected to the tanks on the bus. So if there's an overheat or if there's a pressure issue, you will get an automatic release of that gas through the vent pipes. The tanks themselves go through quite a rigorous test cycle, and there is a test cycle there. In fact, Peter, you could probably explain this better, because you're experienced in this and are looking into it yourself.
Yeah. Okay. In terms of both in terms of hydrogen and in terms of CNG, there's two UN standards, to United Nations standards. The cylinders for both hydrogen and compressed natural gas are subject to what's known as a bonfire test. The bonfire test basically means putting the gas cylinder in a bonfire to simulate a car catching fire. The passengers won't be incapacitated by the gas. If a fire develops in a gas-powered vehicle, in much the same way as any other powered vehicle, effectively there'll be long enough for the passengers to debus and get off that bus. If the fire progresses, safety relief valves will start to vent the pressure, and it's highly unlikely that there would be a catastrophic loss of pressure in terms of the thing exploding. But there will be some fairly significant jet fires from the safety relief devices. You may or may not have seen some of the coverage about what happens when a lithium-ion BEV catches fire. And again, a lithium fire isn't pleasant. And there are issues with both battery vehicles, CNG vehicles, hydrogen vehicles, when they're in things like underground car parks and whatever else, or in tunnels, and they're involved in fires, and the modeling work is involved in that. But certainly, vehicles do catch fire, diesel vehicles, petrol vehicles, hydrogen and CNG. You'll find that the cars that are fitted with 700 bar hydrogen have some of the most sophisticated electronic defense mechanisms, you know, automatic lane changing devices. They've got radar front and rear. And effectively they build those in as a standard to make that car NCAP 5+++. And the cylinders themselves will you know, they'll actually, part of the test and presume is to actually hit them with an armor piercing munition. And what you do is you're looking to see that the hole goes through the cylinder and that the gas comes out with the hole without the cylinder disintegrating. And they all pass that test. So yes, it's a slightly different hazard, and you'll find there's some discussion at standards committees now about whether these vehicles should have hazard signs on to say they've got a compressed gas cylinder on board. But there's a global database of potential incidents, and I can't honestly think of any that I would like to draw your attention to. Yeah. Does that answer the question?
No, that's perfect, Peter. Thank you very much. I think another question here for Brian. Are the dates the government have set out achievable, do you think, or that for the 2030, I think was mentioned in the presentation?
Right. Well, there's a couple of dates Martin picked up there. 2050 is the government backstop for carbon neutral UK, and that covers all energy in the UK, but obviously that includes transport. 2035, a 78% reduction in carbon, so that brings a further pressure forward. There's then also the various dates where the sale of diesel and petrol cars, which I think is a 2030 date. So it's within the gift of government. They have decided that they'll have to create the pathway that allows us all to reach that. From our own personal point of view, our company's point of view, we have put it down our own pathway on our doing a lot of work around developing the business cases to support that pathway. So that is for zero emission in the metro and FIEI fleets by 2030, and the total fleet by 2040. Total fleet being both bus and rail. So it's a pretty big target, but I suppose it's like all these things, you have to set the targets and you have to aim at them and hope you hit them. I do think it is a big job, but I suppose the other thing we should bear in mind is that the infrastructure to support all this is our electricity grid, and the more the focus we have from the electricity grid being green, sustainably produced electricity, then the more likelihood that we can then develop the processes and systems that will utilize that and drive the thing forward. It isn't easy.
Yeah.
I don't think anybody will think it's easy, but
yeah, definitely, and particularly from the health implications as well. It's got to be the way forward. Thanks, Brian. Was just one wee thing I was going to mention there in the chat box there. James has written about the team at Dublin City University. They're kicking off an EU-funded project called High Skills to develop practical training focused on the subject of hydrogen safety skills. And he's mentioned that he's happy to make connections. That might be helpful for anyone in the audience who's looking into the training side of it.
Not only him, the Ulster University runs a very sophisticated, globally recognized MSc in hydrogen safety, and the modules start at £1,200 each if you can find your employer. So if you want to become a hydrogen safety trainer, Ulster's actually setting out to train trainers, and I think that high skills was in some way respect linked to that. We're looking at practical education for technicians, and when I was putting my wee piece together, I was looking at aspiring engineers and attracting the right type of boy and girl into this industry, and where we're going to bring them in. And it's not necessarily through a PhD and a postdoc route. I would have said if they come in at level 3, aiming for a vehicle, electrical or mechanical, and then pick up the skills to level 4, level 5, they'll never be out of pocket. And by the time they get to about 26 years of age, they're in an ideal position with, upwards of 8 to 10 years experience, plus qualifications, plus they're 5 to 7 years ahead of the non-vehicle hydrogen industry.
Mm-hmm.
And in answer to Chris's, Cahal's technicians, I don't honestly see that incentives are required to train trainers. My view is that you as a professional engineer have committed yourself to continuous professional development. If you want to continue to be a specialist in technology that's going to be out of date by 2030, best of luck. But my view is that you need to get out there, get reading, doing your own research, and identifying your own personal agenda about plugging those gaps that you're going to need going forward. And that if you're a trainer, I don't honestly think you need to be bribed to keep doing your job. Sorry about that, but that's coming from somebody who's been self-employed for nearly 30 years.
Excellent, thanks, Peter. I think we'll maybe get one more question here. How much would a coherent hydrogen roadmap strategy by UK government help the UK or NI hydrogen industry?
To be honest, it's already been written. If you look at Element Energy in Cambridgeshire, Element Energy in Cambridgeshire has been doing blue skies thinking since around about 2013 and all this. They've even mapped a route map to get to low carbon vehicles. And the elements of biomethane and bio-LNG and hydrogen and electric, and how they might all play a part in the conversion, because we can't all go to electric vehicles because there isn't charging capacity. So those drop-ins that I talked about earlier on, we're in an area now where the filling stations, the sale of fuel doesn't make money for anybody. It's gone to Tesco, Sainsbury's, Asda's. It's all about, if you put a hydrogen facility into a filling station, you're taking out car parking space for the shop. So you've got to have a much more market focused view about where's the market going, where's the market for your skills as a professional, where's the market for the skills for the young technicians, the boys and girls we're trying to attract into this industry. And I'm sorry I don't have a straightforward no, we should get government to do such. Government's been pumping money into this for, and the EU's been pumping money into this for guts of 15 years.
Yeah. Thanks very much, Peter. I think we'll close the webinar there, folks. I'd like to thank Peter, Martin, and Brian for assisting us this evening. For the audience, I hope we've answered all the questions and if you do have any other ones, please do feel free to contact me on LinkedIn or through the SOE. There was one other comment there. It was just, is the webinar recorded? It is, and it will be available at a later date to view whenever, if you would like to look at some of those links, for example, that Peter had put up. Thanks again, everyone, for joining us this evening. I hope you've enjoyed the webinar and you found it informative, and good night.